Hello, welcome to LeetCode Solver. Today we are going to solve uh, 15, 16, 17, 18th problem in May Leetcoding challenge, and the problem name is permutation in a string. Permutation in a string. Given two string s1 and s2, write a function to return true if s2 contains permutation of s1. S2 contains permutation of s1. In other words, one of the first strings permutation is substring of second string. AB, it has BA somewhere here. Okay, it seems like the problem is same as yesterday's problem where we had to find the indices of every possible permutations to the given um, another string. So here we just have to return true or false based upon whether it exists in another string or not. So, and problem definition for yesterday was like checking anagram or not. The anagram is also, I mean, same as the permutation because the every character should have the same frequency and consist of the same combinations of characters to the another string. Well, we can do the same thing, and we can solve it in big O of n, where n is the size of the s2, and yes, that's it. And for space complexity, we can use the same thing, like space of maintaining the map for 26 character, I guess, lowercase letters. Yeah, that's it. Let's solve the problem then. First of all, we have to find the size of m, which is equal to s1 dot size, which we will be looking at n, which is the s2 dot size. And if we found that m is greater than n, or if the character string we are checking is bigger than s2, then definitely its permutation will not be there. Or if we see that either of one is not exist, I mean null, like either m null or n null, I mean empty string, then we will return false in all those conditions. Otherwise we will hold a hash map which will contain the frequency of every character ch in s1, which we will be holding in hash map. Hash map of every character will be increased. And let's define hash map on our dot map of character with their frequency. And we will be trying to next time we will iterate over s2, and we will, for every substring of length m, we will try to match with this frequency. And let's say for every substring of length m, so if I is less than m, we will just push it in another map, say on our dot map, say frequency map frq, and we will just, for every character we will just s2, every character in s2 we will just increase their frequency. Also we will maintain if their frequency is frequency of s2 of I, if it is equals to hash map of s2I, if it is frequency equals, in that case the I will increase character count and total character. Total character we are interested in are hasmap.size. This was a distinct character we are interested in, and character count is currently 0. If it becomes equals to, like frequency is same as that was in hasmap, we will increase a character count by 1. While increasing, if we found that frequency of s2 of I is equals to 1 plus hasmap s2 of I, if it becomes greater, then we will just remove that matching and it will become, we will decrease that matching if it is I is less than m. Otherwise, in other cases, if I is greater than equals to m, we have to remove the other characters. So character to be removed, to remove equals to s2 of I minus m. That character we have to remove, and this thing is happening every time, so we can simply keep it as it is without any condition. And if we found that I is greater than equals to m, only that situation we will be doing subtraction. So to make it simple, let's do it only if I is greater than m. Okay, if I is greater than m, we have to remove this character. So let's remove this frq of character to remove will be decreases, and if we found that frq of character to remove is equals to hasmap value, hasmap of character to remove, if it equals by decreasing, then we are nice, we will increase our character count by 1. Or if it is equals to by removing it, if it decreases just below of what is necessary, like if it becomes hasmap of character to remove -1, if it becomes this, then we have to remove our character count. So this is invalid situation, so we just removed it. Yeah, that's it. Now we just have to check if we found that character count at some point of time is equals to total characters, then we will return true immediately. Oh, sorry, return true. And if somehow we have to reach up to this point, we will return false because the permutation do not exist. Let's run the code. True, true. Let's try with the cases A, B, and we expect this in A, C, B should be false, and A should be true. D, and D is here, should be true. Okay, so let's submit and see if there is any corner cases or anything we missed. Accepted. Okay, all right. So complexity is big of n, where n is the size of S2, and space complexity is big of characters, big of total number of characters 26. So yeah, and let's we can also elaborate how does it works for this as well, for this case. Okay, all right. Initially, we have a hash map which will be filled up like this. A will have frequency of 1, and B will have frequency of 1 as well. Now, when we go through this, we see that we will be, this is a hash map actually. Hash map looks like this. Hash map will not change. Just after filling up hash map, we will not be changing hash map, but we will be changing our frequency map, which is initially empty. It has nothing, and by going through the this string, we will be populating frequency. So if we reach to 0 point, we have now entry of E, and which will have frequency of 1, and nothing satisfies over here. So now in next move we have I in our hash map, which have frequency 0, oh sorry 1, and in next move we have D, which have frequency 1, and in next move we have A, which have frequency 1, and as we are increasing, as we were increasing, oh sorry, there is B as well. A, I, B, D, oh no, D, then B, not A, B. We increase 1. So when we increase 1, we are also decreasing. So I, after addition of E and I, when we reach here 0, 1, 2, so this is of size 2, right? So when we reach to 2 index here, it will be decreasing the character frequency. So E will be 0, and now in next move, when we move to B, B will be increased to 1, and so at the same time when B increased to 1, our character count is increased to total characters are 2 here, and our character count is now increased to from 0 to 1, because B matched with its what was expected here, so we increase character count by 1, and in the after increasing B, we will be removing I, so I frequency will be decreased to 0, and in next move we have A, and when we reach to A, we increase its frequency by 1, and it matches with its original frequency because it was previously nothing, and from nothing to 1, so it matched. So we can now make it to 2. Yes, when we match 2, now we have to remove here, this code will be executed, so we will be removing D to 0, and after removing D to 0, we see that B and A have total characters are equal to character count, so we will be returning true in the meantime. So rest of the code will not be executed, we will be returning true here. This way the algorithm works. Yes, thank you so much for watching this video, hope it helps you, and if you have any query or any alternative solution or anything else to say, please feel free to comment, and see you in the next video. Have a nice day.